Hi there. We're going to do some practice problems with some Riemann sums. We'll focus on right, left, midpoint, and trapezoidal. So you get a feel for how it all works together. So let's take a look. We're given a table of values, which is how we primarily see Riemann sums being tested on the AP exam. But notice here we're being asked to find approximation for the area from -3 to 1. So that's telling me that in my chart, I'm only using going from x being -3 to x being 1. And then we were told we want to use two subintervals. Well, that's pretty easy to see in the chart. We'll just go from -3 to 1 and then go from -3 to -1, and then we'll go from -1 to 1. And we want to use a left Riemann sum. So, okay, my first rectangle, the width is going to be 2. And we're going to use the left endpoint to get the height, which will be 5. Let's do the next rectangle. It has a width of 2 here. Notice from -1 to 1 is 2. And then we're also going to use that left endpoint to get the height, which is 2. So we get 14 there. Okay. Now let's look at the next one. We're going from -3 to 9. So we're using all of this data here, and we're going with 3 subintervals. So it looks like my subintervals, and I'm going to do this with a pencil so that I can erase it. So it looks like my subintervals are going from, we're skipping one each time in order to get 3 subintervals. There we go. Okay, so my first subinterval, my first rectangle goes from -3 to 1. That's a distance of 4, so my width is 4. And we're using a right, so we're going to go to the right endpoint and get the height, which is -3. My next rectangle goes from 1 to 5, so the width is 4. And we're going on the right endpoint to get the height, which is -2. Then we're doing our last rectangle from 5 to 9, which has a width of 4, and we're using a right endpoint, which is 11 there. So now we just do some multiplying, and it looks like I get 24. Okay, now this one we're also going from -3 to 9 using 3 subintervals. So I'm still going to use those same subintervals that I have drawn, but I'm using a midpoint sum. Okay, so my first rectangle goes from -3 to 1. That has a width of 4, but I'm going in the middle to get my height, which is 2. Then I'm going from 1 to 5, which has a width of 4, but I'm going in the middle to get my height, which is -7. And then from 5 to 9 has a width of 4, and we're going in the middle, which is a 6 for my height. And so I get 8 plus -28 plus 24, and that is 4. Okay, now I'm going to erase those so I can draw my widths. I picture it better when I can see it. Okay, so this time I'm going from -3 to 3, 3 subintervals. So I'm going from -3 to -1. I'm going from 1 to 1, and then I'm going from 1 to 3. And I'm doing a trapezoid. Okay. So remember, formula for a trapezoid is 1/2 times the height and then add the bases. Okay, so let's do that first trapezoid. 1/2. Now my height is actually the distance on the x here. So the distance here is 2. And then we're going to add those bases. So 5 plus 2. Then I'm going to do a half. We'll do the next trapezoid from -1 to 1. That has a height of 2. And then we're doing adding the bases. 2 plus -3. Okay. Then I've got a half. Going from 1 to 3 is a height of 2. And again, we're adding those bases, -3 plus -7. Okay. So 2 times the half goes away, and 5 plus 2 is 7. 1/2 times 2 goes away, and I get -1. And then 1/2 plus 2 goes away, and I get -10. So -4 there. Okay. All right. And then our last one here with this chart, again, I'm going to erase so that I can see my widths here. I'm going from -3 to 9 with 6 subintervals, and I want trapezoidal rule. 1, 2, 3, 4, 5, 6. Okay, so I've got each of my widths is 2. We know that from our previous problems. And so we're really just going to add these bases up. So I've got 5 plus 2. And then I've got 2 plus -3. And I hope you can see that the 2 was added twice. Then I've got 1/2 times 2, and I've got -3 plus -7. Okay, and then I'm going to do 1/2 times 2, and I've got -7 plus -2. I'm going to jot down here 1/2 times 2, and then I've got -2 and 6. And then I've got 1/2 times 2, and I've got 6 plus 11. Okay. Now realize which ones were added twice, right? All the ones in the middle were added twice. Okay. So really this became 5 plus 2 times 2, because we've got 2 of them, plus 2 times -3, 2 times -7, 2 times -2, 2 times 6, and then adding 11. So the ones on the ends were added once, but the ones in the middle were added twice. Okay, so that's 9 and 3, -11, -15, -3, 8. Okay. So practice with your trapezoidal, practice with your left and right. Those are very important. Now for our next piece, I'm going to use the graphing calculator to help with the values. So you can see here, I've gone to our calculator, Desmos, and I'll link it below so that you can access it as well. But we are trying to find the area from 0 to pi of this function. So what I've done in Desmos is I've put that into, and I've labeled it f of x. Then I asked Desmos to build a chart. And the way you do that is to use the little plus here, and you can choose table. Now, be careful though, you have to change this labeling to f of x sub 1. And that's because this first column is labeled as x sub 1. And because I want 4 subintervals from 0 to pi, then I know that each x value needs to be a multiple of pi over 4. So I'm just typing these in. So I'm going to get the calculator to do the heavy lifting with my values. So I don't actually have to find them, like calculate them by hand. Okay. And then I'm going to use these. I'm using a right Riemann sum. So notice that my width of my rectangles is going to be pi over 4. And I'm using the right endpoint to get my heights. And so from 0 to pi over 4, the right endpoint would be this height. And that is 1.10, sorry, 1.111. And then my next one would be 3.142. And the next one would be 3.332. And the last one, of course, would be 0. Notice something with the right hand is that we leave off the first one. So I'm going to put this in my calculator. And I'm just going to add up those decimals. And then I'm going to multiply by that, and I get somewhere around 5.953. Okay, using a right Riemann sum. But notice I can use my calculator to populate those values. Now, notice on number 7, we need to change the function. So I can easily do that here in Desmos. We're doing e to the second and then x squared. But we want to go from -2 to 10 with 4 subintervals. So that means from -2 to 10 is 12 long. If I want 4 subintervals, then each one's going to be 3. So I'm going to change my x values here to start at -2. And then the next one would be 3 away. That would be 1. And then the next one away from that would be 4. And the next one from that would be 7. And the last one would be 10. So I'm hoping you see how I divided those up. Okay. Now we're doing 4 subintervals, equal length trapezoid rule. So remember on trapezoid rule, it's 1/2 times the height or the width here, which of course we said was 3. And then we add the first one, that's 29.556. We're going to double the ones in the middle. So 2 times 7.389 plus 2 times 118.225 plus 2 times 362.064. And then we add the last one without doubling, 738.906. Okay, so that's your shortcut for trapezoid rule. Let's add those up quickly. And I get 2,615.727. And again, using that table on our Desmos really, really helps because it keeps you from having to crunch all those numbers. Now I'm going to switch our view back for the last two here because they are table problems, meaning the values are already given to us. This one we're asking to approximate the area from -2 to 9, and we want 3 subintervals. So let's divide that up. So we're going to go from -2 to 1, then we're going to go from 1 to 5, and we'll go from 5 to 9. So my widths are different. I'll have to be careful with that. And I'm going to do my first rectangle, the width is 3. But I'm going in the midpoint to get my height, which would be 8. Then I'm going from 1 to 5, which is a width of 4, and my height would be -4. Again, going in the middle there. From 5 to 9, my width would be 4, and my height would be 2. So I can add those up. Looks like I've got 24 plus -16 plus 8, which gives me 16. Okay, and then we're going to use the same table. This time we're going to do 6 subintervals and we're doing trapezoid rule. Now be real careful on this one. Notice with 6 subintervals here, we actually get different widths, which means we can't use our rule of add the first one and then double the ones in the middle. We've got to do these trapezoids separately because they have different widths. Or remember, our trapezoids are actually standing on end. So this would be their heights. So my first one, the height is 2, and we add those bases. Okay, my second one, my height is 1, and we add those bases. Okay, my next one, my height is 2, and we add those bases. Then we go from 3 to 5, width of 2, and we add -4 plus -1. We've got 1/2, and then we've got a width of 3, and then we add -1 plus 2. And then finally, we got the last trapezoid is from 8 to 9 with a height of 1, and we get 2 plus 5. Okay, so I get 13 here. Here I get 10 times a half is 5. -2 times 1 is -2. -5 times 1. I've got 1 times 1.5. Let's change that to a decimal. And then I've got 7 times a half, which would be 3.5. Add those up. Let's see, 18, 16, 11, and 5 gives me 16. So I hope this helps with the trapezoid rule, with the Riemann sums. Keep practicing with these because you're going to see them from a chart, primarily on the AP exam, but you never know. So keep practicing, friends. If you have questions or comments, please leave them in the comments below. And don't forget to hit like and share. That way you get a notification every time a new video is posted. Bye for now.